All right, so we're going to go ahead and get started. Hey everyone, welcome to the second session of You're Doing It Wrong. Today we're going to be covering Rhino and Grasshopper, and I'm super excited about this session because Rhino and Grasshopper are really close to my heart as a designer. I've been using them for quite some time in my years studying architecture and landscape architecture at the University of Tennessee. And Rhino provides a lot of flexibility that allows you to be more flexible with your design practice than a program like Revit, which will be in a later session, which is a lot more constrained, but provides a lot more ability for documentation. With Rhino, definitely use it for the early design process or the entire design process because it's very flexible and very powerful for generating form and other typologies like that. So one quick thing. So the sessions, I want to go ahead and show you the roadmap. But let me tell you a little bit about YDIW before we get started here, if this is your first time here. You're Doing It Wrong was a tutorial series that I started when I was in college at the University of Tennessee. I was always the guy that people would come to when they had questions about software. And I also had to get my work done, so I wanted to create this tutorial series to basically dump all of the knowledge that I had acquired over a lot of the software that we use, and dump it all into this tutorial series, upload it online, and have it be something that's accessible and ready to use for a lot of people. So the idea is that technology is moving very quickly, and I want everyone to be able to keep up to date with the latest technologies and work smarter and not harder, and utilize the strengths and be aware of the weaknesses of each software so you're never really bottlenecked. I believe that a designer should be versed in all tools available to him or her so they are never bottlenecked by the lack of knowledge of any specific tool. So it's important to be in the know. So this is the roadmap. The first session was on Photoshop, which was last month. This month it's Rhino Grasshopper. Next month will be InDesign. Next month after that will be Illustrator, and then Revit. And then Dynamo, Enscape, and Lumion. I'm going to do those two together since they're very similar. Geographic Information Systems, or GIS, will be in October. Premiere Pro and After Effects, I will also do those two together in the same session, will be in November. And Bluebeam in December. And in 2020, I'm thinking about introducing new software or doing advanced versions of software shown this year. So definitely reach out to me on social media at the You're Doing It Wrong channels, Facebook, Instagram, Twitter, whichever you feel comfortable with, and let me know if you have some ideas on future roadmap developments. So really excited about these sessions. Because it allows us to really explore all of the different tools that we as designers use on a daily basis. Okay, so this session on Rhino and Grasshopper. The goal of this session is to be both an introduction to Rhino and an introduction to Grasshopper, since a lot of the people watching this right now have never used Rhino before. And if you've never used Rhino before, you've definitely never used Grasshopper before, because Grasshopper is a plugin for Rhino. So with this session, it's going to be an intro to both Rhino and Grasshopper. And we're going to be talking about rapid iteration, form generation, and making smarter models. So the software in this session, of course, is Rhino and Grasshopper. Grasshopper is a plugin for Rhino. You cannot use Grasshopper without Rhino. And in fact, in Rhino 6, which is the newest version of Rhino, Grasshopper is now baked in. It used to be a plugin that you downloaded separately. And it was actually developed by someone else other than McNeil. And McNeil, who develops Rhino, thought it was so powerful that it's something that they wanted to include, and they have, which is awesome. So the file types in this session that we're really going to be talking about, in the last session with Photoshop, we spent a lot of time talking about raster files. And raster files are pixels, and pixels are little squares of light information that show an image, basically, once they're all combined together. Vectors are different. Vectors are actually math equations, and that means that they are infinitely scalable and infinitely replicatable. Raster files will lose resolution based on how big they become, But with vector files, you have a lot more power. And so all of your CAD-based programs use vector information to compose the geometry. One quick second here. If you want, you can turn up the brightness on the projector. It should be a button on there somewhere. And please feel free to stop and ask questions. So I want this to be interactive. But yeah, so right now I feel like a presenter right now because I'm presenting to an online audience too. But definitely feel free to stop me if you have a question. Right, exactly. Okay, so we're going to be working with vector files, and the main file format that a lot of vector files use is the DWG. I call it the almighty DWG because if it's a CAD program that's worth its salt, it can import and export DWG files. Rhino files, though, use our 3DM files, which is a file format proprietary to Rhino. But Rhino has the ability to export in a lot of different vector file formats and also some raster ones as well. So this file format is going to be one that we're using if we're doing interoperability between Rhino and AutoCAD or Rhino and Revit or Rhino and Illustrator. Okay, so let's talk about what a vector is. Vectors are mathematical equations that have a couple aspects to them. So a vector can either be drawn by creating 2 points in space and then connecting those 2 points, or they can be created by using a magnitude, which is the length, and a direction. And so vectors are used in a lot of different math equations and computer and computational processing because of how simple of a form they are to generate based on the math. And that's why they're infinitely scalable, is because it's a math equation and not a set of pixels. So all vectors are either a connection between 2 or more points, or a magnitude, which is length, and a direction. Let's talk about how vectors are used inside Rhino. So Rhino employs what's called NURBS modeling. And don't worry about what NURBS actually stands for. What's important to note is the different aspects of NURBS geometry and what they mean. Because when we get to the Grasshopper section, you're going to want to know deeply about the geometry that you're manipulating for you to be able to tell a computer how to do something. So NURBS geometry starts with a single point. A point is the most simple geometric form you can create. It's 3 coordinates, an x coordinate, a y coordinate, and a z coordinate. And when those 3 numbers are combined together, you generate a point. Super simple. Then we get to curves. And curves are what Rhino calls vectors. Now, the reason why they're called curves is because they have the potential to be curved. Now, Rhino also calls lines curves. So think about it this way. You know how you can get, let's talk about rectangles and squares. All squares are rectangles, but not all rectangles are squares, if that makes sense. So all lines are curves, but not all curves are lines. So curves have the ability to be curved. They could be a curved vector with multiple degrees, which I'll talk about in a second. But lines as an object are always straight. Right? Always a connection between 2 points. Curves have a potential to be curved, but all vectors in Rhino are considered curves. And a curve, if you think about it fundamentally, is an extrusion, an infinite extrusion of points. So that means that if I have a curve, I can extract a point from any location along that line. So if I wanted to point at 50% of the line, I can get that. If I wanted to point at 0.3578% of that line, I can get that. So all curves are infinite extrusions of points, and I can divide that curve in an infinite number of ways. The same thing with surfaces. So surfaces are an infinite extrusion of curves. So if I have a surface, I can extract a curve from any point along that surface. And I can divide that surface an infinite number of times. in both what's called the U and V direction, and we'll talk about that when we get into Rhino. But every surface and object has a U and V direction, which is basically the local X and Y direction of that surface. So a surface's coordinate system can exist separately from the world coordinate system in terms of orientation and mapping of the surface. And then another type of geometry that Rhino can edit but is not NURBS geometry is called the mesh. And meshes are basically polygonal faces that are combined together. So they're either a triface or a quadruple face, which means 4 points. Triface uses 3 points. And a lot of three-dimensional modeling actually uses mesh modeling to create it. So for example, if you've ever played a video game, and I know we've all played a video game at least once in our lives, some of us are better at them than others, all the objects you see in the video game are designed and built using mesh geometry, since it's a very simple form to generate, and it's much easier to compute than, for example, NURBS geometry, which you would not want to build a video game out of. But NURBS geometry is great for modeling objects. So that's using vectors in Rhino. Now let's talk about curves and what that means. So when I mentioned degrees before, every line has a degree, and the more degrees a line has, the more curves a line can generate. So a 1 degree line is a line that has 2 points, and it's a straight line. So in Rhino, that's why I was talking about lines and curves. A line is a curve that has 1 degree. Now, a curve that has 2 degrees will have a curve to it. So sorry about the terminology is a little funky, but a curve line has at least 2 degrees. And you're typically working with a line that has at least 3 degrees. So those points that you see there are control points that allow you to manipulate the way the curve looks. So if I grab this first control point and I pull it up, the line will also follow a more exaggerated curve. And so these control points allow you to control the actual curve that you get there. And you can have up to, I think, 8 degrees or more in terms of the manipulation of a line, which is pretty cool. And so you'll see that manipulation as we get into Rhino. Okay, so let's talk a little bit more. Let's talk about Grasshopper and what it does before we start. And this is really important to understand, because the goal of these sessions is not just to show you how to use it, but the software, but to help you understand fundamentally what you're doing, so you can ask the correct questions to find the correct answers to what you're looking for. So when you understand that, oh, I'm working with a surface, which is an infinite extrusion of curves, or oh, I'm working with a curve, which is an infinite extrusion of points, or oh, I'm working parametrically, which means when I make a change here, it's going to affect another change down the road. I want you to be able to understand that. So parametric is basically another way of saying coding, scripting, or algorithms. And so it's a specific set of workflows where you have certain parameters that are related to each other. So for example, if I have a surface, and that surface is divided into a series of 100 points, those points are attached to the surface itself. So if I modify the surface, the points themselves will also be modified. So you can actually string a lot of these parameters together to have relational geometry that can talk to each other, basically. And this allows for a lot of flexibility in your workflow. So you're not working on something multiple times. So for example, if you're building something in a program like Rhino without Grasshopper or Revit, and you want to make a change, you have to make that change for every instance you want to. So if you've got, for example, if you start with a rectangular slab and you now want to make that slab curved, all of the geometry you've built for that rectangular slab will now have to be modified for the curved slab, and you'll have to do that manually. Versus working in Grasshopper, where all of the curve geometry is based on that rectangular curve. So if you change that rectangular curve, all of that geometry will also change. So Grasshopper. So whenever you think about code, most times people default to lines of code that you've seen on websites or different movies or something like that, where you see the coder who's just coding away on a bunch of lines of code, right? Now, all computers basically run on code, and so does Grasshopper. But what Grasshopper does is it basically gives you a graphical visual interface for manipulating that code. And that's called node-based logic, which allows you to skip the learning curve of line code and get directly to the power of algorithms without having to learn how to code. So without having to learn Rhino script or Python or R or C++ or HTML, which are some languages that I actually would like to learn. But yes, question. Node-based logic or node-based coding. So what that means is that you have nodes that connect to each other, and that connection basically relates them as if you were creating lines of code with them, which is super cool. Rhino and Grasshopper also have a bunch of plugins that go with them that further augment their abilities. Here are just a few plugins. So take a screenshot of this portion here, and we won't get into much of them today, but these are definitely worth looking up later on. So for example, Kangaroo brings physics modeling to Grasshopper. Paneling tools allows you to take a module and panelize an entire surface with it, which is really cool. Lunchbox does a similar thing. So there's a bunch of tools that you can download that help you do a little bit more with Rhino and Grasshopper. Okay, so fundamentals of scripting. So we've talked about what parametric means. We've talked about Grasshopper and what it does. But here's how to fundamentally understand here's how to fundamentally understand scripting. If you understand this, then you can get scripting. So all scripts are just inputs, which is the what is happening, what is the input, what is the initial data that is to be manipulated. Then you have a command, which is a function that's run on the original input that you've given it. And then that gives you an output. So input, command, output, which is the result of the function run on the initial input. Now, what's really cool about Grasshopper is that all outputs can then become inputs for another set of commands. So the output of one command can become the input of another. So if I've moved a point, I can then connect the point with the original point and generate a line. I can then take that line and extrude it to make a surface, and etc., etc. So you're taking commands, inputs, you're running them through commands, and you're getting outputs that then become inputs for another set of commands, etc., etc. So if you understand this, you can build your own scripts, because really all you're doing is just transferring what you do manually already anyway inside Rhino, and you're telling a computer to do the exact same thing. And so you have to break down each step. Here's what you're supposed to manipulate. Here's how you're supposed to manipulate it. Here's by how much you're supposed to manipulate. And then take what your result and do something else with it. So a simple example of what a Grasshopper script looks like. And then we'll get into Grasshopper after this in Rhino. So we're moving a point here. Now, if you're going to move a point manually inside Rhino, you're going to create the point in the first place. Then you're going to type in the move command. The move command will ask you a couple questions. What am I moving? And in which direction? And by how much? And you type those instructions in. So move in the X direction by 10 units. And I'm going to say units for now because it could be feet, meters, inches. It doesn't matter. And then you hit enter, and now the point has been moved, and you've done that manually. If you want to repeat that process, you would type the move command again. You would select the object again. You would move the object again, and then you would repeat the process again if you need to. Versus building a script that does all of those steps automatically, and so all you need to do is provide the input, and the script will run and give you the output. So breakdown of the script, right? This is the input. This is the start. This is the initial data that's being manipulated. So we now have the what. We then have a command called move. Now the command is requiring 2 inputs to work. Now not all Grasshopper scripts require all of their inputs to be satisfied for them to work, but in this case you do need both inputs to work. And the inputs that, yes. Oh, and the inputs that it's asking for are geometry, and geometry is a catch-all type, and the types are really important in Grasshopper, and we'll see that in a second. But geometry is a catch-all type, so it can take points, curves, surfaces, and B-reps, which is another way of saying polysurface, and we'll get to that too. So geometry is a catch-all, so we can plug the point into geometry, and now we need to tell Grasshopper in which direction and by how much we're moving that object. So you create a unit Z component, or unit Y component, or unit X component, or a vector which can be pointed in any direction, and we'll see that too. And then a number slider that's set to 10, which is going to tell Grasshopper to move that point in the Z direction by 10 units. And the units Grasshopper uses are the units your Rhino is set to. So if your Rhino is set to feet, it'll be 10 feet. If it's set to meters, it'll be 10 meters, etc. And so now the component's run, and now it's spitting out two outputs. And you really only need the first output in this case. Sometimes you'll need both outputs or more, but in this case, you'll just need the move geometry, and we'll place that into another point component. So now this is the output, and you can see all components, or most components, have an input node and an output node. So that point can then be output or input into another set of scripts to do something else. But this is a very simple example of how Grasshopper works. And if you get this, you can build your own scripts. Okay, so let's get into it. What we're going to do is jump into Rhino, and we're going to do some things in Rhino. I'm going to show you the interface, show you some commands. A lot of these commands that Rhino uses are very similar to other programs that you may have used, like AutoCAD, like Revit, like SketchUp. A lot of these modeling programs use the same commands. And so if you understand the type of command you're going to run, it's pretty easy to learn another 3D modeling program if you know one already. So this is Rhino. Let's walk through the Rhino interface quickly, and then we'll start creating some geometry, and then we'll get into Grasshopper. So when you first open Rhino, you'll have 4 panes here, and these 4 panes are views. So the one on the top left is the top view, which is looking down in plan. The one on the top right is perspective. And perspective view allows you to rotate around the object for 3-dimensional viewing, which is great. And then you'll have front view, which is an elevation view, which looks directly on from the front, which is the south in this case. And then the right view, which is east, looking west. Now you can change these views. If you want a different view, you can click on the little arrow here. Yes, question. How do you orbit in a perspective window? Oh, good question. So to orbit, you hold the right button on your mouse. So when you hold that, you can then orbit in perspective view. To pan, you hold shift and click right again. Good questions. Now you can change the view of the viewport. If you click on the little arrow next to the name, you'll see set view, and you can change that to bottom, left, front, perspective, 2-point perspective, which is great for doing axons, which keeps all your verticals straight, which is cool. You also have isometric, which allows you to bias the perspective view to northeast, northwest, southeast, or southwest, and it'll be an ISO, which is not exactly an axon, but it's pretty close. It keeps all of your parallels straight, so there won't be any intersections in your parallels in the perspective view. If you want to make one of the viewports bigger, just double click on the name, and that will become the dominant viewport for you to use. So just make sure that that is the case if you need to make that big. To make it small, just double click on it again, and you've got your 4 views. You can also have one view be bigger, so if you want to remove a view and make one view dominant, you can do that. So I'm just gonna close that viewport and make perspective extra big, just so we can see it bigger here. So you can manipulate these. If you've got rid of one and you want to bring it back, you can just right click in this black space. Oh, my perspective is now gone. Oh, right. Okay, so I'm clicking the right button, which is redoing the last command. and it's getting rid of my viewports, so we're not going to do that. I'm going to type in create or viewport properties, new viewport. That's the command. There it is. I'm going to bring it back and right click to redo the last command, and right click again to redo the last command, and then set these views to what they should be. So I'm going to set this back to perspective and set this back to left or right. Okay. Right, so that's viewports. Now, overall interface, great question from before. To move around, you want to use the right button. If you click and hold, it allows you to orbit. Shift allows you to pan. The zoom wheel allows you to zoom in and out of all views. The active view is whichever one your mouse is on top of when you use the command. The right panel here that you see has a bunch of tabs. You have properties, and the properties will change based on the object that is selected. If no object is selected, then the properties will be the viewport properties. So you'll see the width and height. You'll see the lens length, which you can change to see more or less of a perspective, for example, and a bunch of other options there. If you select an object, you'll see the properties change to the object properties. So you can edit things like the layer that it's on, the display color, line type, thickness, materiality, etc. You'll also see display, which is super important. Display allows you to change the way your Rhino looks. So if you wanted a dark gray viewport, if you want it to look more like AutoCAD, you can do that. If the background is set to solid color, there are a bunch of other types there. You can do gradients, you can do image files. In this case, I like a light color palette, so most things show out. In some of your views, you'll have a grid. I've turned off the grids because I never use them. So to manipulate your grids, if you type in show grid, or sorry, if you just type in grid, when you enter a command, similar to AutoCAD, the command window is up here, and you'll see a bunch of different options. Every time you open a command, always read these options, which give you more power in the edits that you're going to be making. So for example, the one I'm looking for is show grid, and right now that's set to no because I set it to no. So when you click on that, then this is changed to yes, and the grid pops up, and you can manipulate how big that grid is if you are using the grid. In this case, I just never use it, so I always keep it off. But that's command. So when you type in a command and you hit enter, always read the little options there because they give you additional abilities with that command that are important. Then your layers panel, which is, in my opinion, the most important panel. I can't tell you the number of times I've looked at someone else's model or file and they have one layer and everything is on that layer. I can't tell you how freaked out I get when I see that because I know they're working harder than they have to. So always use layers for every different type of object. If you're working with a surface and that surface is the ground, have that on a different layer than your glass and steel and concrete. Please, dear God, make a different layer for every type of object because materiality is tied to layers. So if you want your glass to be transparent, but you don't want your floor to be transparent, have them on different layers, for God's sake. Okay. To create more layers, you click the little new layer button and a new layer will be created. By default, Rhino gives you 5 layers. I deleted them because I want to create my own layers, and you created a template file. But you can delete, add, and move layers around. To move layers, you'll see these arrows here. You can move up and down. If I create another one, if I wanted this to be up, just move it up. If you click on the layer once, the layer name, you can change the name. Which of course you would want to do. You can also nest layers to create groupings. So for example, if this was labeled building, and under the building nest I had walls, and then I can create a new layer under it and call that floors, etc. I can set their color. So if I want them to be different colors, I can do that. So let me create a quick object here. Let me create 2. And then I can change the layer an object is on. So if I click on the layer and go to change object layer, that now lives in the Wallace layer. And if you want to make sure the object is on the right layer, just go to properties and you'll see layer walls, which is awesome. If you don't see a tab that I'm working on, just right click and you'll see all of the toolbars. The ones that are the most important to have on are properties, display, layers, and named views. Those are the ones I always have on. If they're not on, I create them. So properties, display, layers, and named views. Always important to have in your toolbar. And let's put this on floors just because. So if I click on an object and I right click on a layer, you'll see a bunch of options. You'll see change object layer and copy objects to layer, which will create a copy and place it on that layer, but the original object will be on the original layer. You'll see options like duplicate layer, which will only duplicate the layer and its properties, so materials, color, etc., but it will not copy any of the objects. If you want both the layer and the object selected, select that option. So using both will allows you to have more flexibility when you're manipulating your layers. You'll see delete layer, name layer, all of that. So always read these options when you right click on a layer to see what you can do with them. Okay, so that's layers. Named views. If you're familiar with SketchUp, you're familiar with scenes, and scenes allow you to get to a specific view automatically. That's the exact same, so you can do things like export renderings, drawings, and things like that. In Rhino, it's called named views. So right click if it's not there and select named views to bring it up. And to create a named view, you hit the save as icon and you give it a name. So we'll call this perspective 1. And so that named view has been created. So if I orbit in a different direction, I'm doing some other edits, and I want to get back to that exact view, I just double click on perspective 1 and I'm put back in the view. Always, always, always do this before you export for your drawings. If you've used Rhino for a long time, you know exactly what I'm talking about. Okay. All right, so that's the layers panels that matter. There's also materials, which is important, rendering, etc. Yes, question?
How do you bring your panels back if you accidentally close them?
So which one is missing? Just a panel or the whole thing?
The whole right side is
Okay.
gone.
If any of your panels are gone, type in the name of one of them. In this case, I would type in properties and hit enter, and that'll bring properties back. And usually it brings back a bunch of others, and then just snap them to the right. You're welcome. Okay. On the left side, you'll see your toolbars. These you will become very familiar with. So your pointer tool, which is just used for selecting things. Drag select in both directions still works as it does in other programs. So dragging starting from the right and moving left selects anything that's touched by the window. Dragging from the left to the right only selects what's fully encompassed. Really handy when you're working with a lot of objects. Your point tool, which creates a point, which is pretty handy. If you click on the down arrow, you'll see other options for points. If you want to place multiple points at the same time without having to reinitiate the command, that's under the point command. So now I can place as many points as I want. And I'm going to get through this pretty quickly. The polyline tool, which creates polylines. The curve select creating tool, which creates curves, which is also really handy. So you can see here that this line is based on degrees. So it's approximating the line based on where I click the points, which is super handy for creating curves. Circle tool. And if you click on the other option, you can see other ways to generate a circle. So if you wanted to generate a circle based on 2 points, you can do that. Rectangle tool, of course. If you use the rectangle tool and you hold shift, it will create a perfect square, just like other programs. A bunch of other tools like that. Surface tool. So the first command here is surface by 3 or 4 points. That's a 3-point surface. This is a 4-point surface. If you want it to be a perfect rectangle, click on the drop down, click on the surface by 2 points command, which allows you to generate a perfectly or orthogonal surface. Sphere command, a bunch of other commands. Another command that's really important is the points on command. So this used to be more important in Rhino 5 than it is in Rhino 6. In Rhino 5, you used to have to select a curve and click on the points on command to see its control points to manipulate them. Now in Rhino 6, the points are always on, which is great. When you select a curve, you can go ahead and immediately start editing that curve. Same thing goes with curved curves. So you can select control points and you can move them around like so. Okay, so that's that. You've got a bunch of commands up here. You have toolbars, and this is also another pet peeve of mine. I've seen a lot of Rhino files with very experienced Rhino users who have a bunch of tabs and a bunch of empty space that's just floating around. Please keep your workspace clean and organized so you can see more of the file that you're working on. So if you have a bunch of toolbars that are just single toolbars and then there's a bunch of white space, that's wasted space. Keep things clean, keep things tabbed. So all of these tabs come baked in. When you install a new plugin, you'll probably get another toolbar, which I recommend taking and docking so it's nice and clean. So for example, if you installed V-Ray, which is an excellent rendering program, it creates a bunch of toolbars. Get those toolbars docked so it's nice and clean. So that's all of these. So your zoom commands, your pan commands, orbit commands, all of that stuff is under standard. Save as, which is a drop down, or you can go to file, same thing. You've got some fundamental commands at the top here. So curve and surface, solid. All of these commands have a bunch of really powerful options. Please explore these if you're looking on how to. For example, if you wanted to draw a helix, you can go to surface and helix is one of those options. Or if you want to draw a sweep, which is a surface that's extruded along a line, there are two types of sweeps there under surface. So if you don't know if a command exists, do a hunt for it and see if you can find it. Again, like I said before, all NURBS geometry is an extrusion, infinite extrusion, of the type of surface before it. So points, curve, surface, B-rep, or polysurface, which is a conglomeration of a bunch of different surfaces, right? All of those are extrusions. So if you go to the curve command and you go to the very bottom, you'll see curve from objects. A bunch of amazing commands are here. So duplicate edge, which allows you to basically create a curve on the edge of an object. So when I click the command, I got a bunch of options here. For example, this option is output layer, which means when I create this curve, Paul, where do you want me to put the curve? Output layer is right now set to current. So if I go to my layers panel, the current layer is default. So when I create this curve and I hit enter to confirm the command, that curve that I've just created exists on the default layer. So if I go to properties, you'll see it as default. If I repeat that command, so curve from objects, duplicate, let's do duplicate face border. This will be looking for a surface, and what I'm going to do real quick is change the view type. So right now it's set to wireframe, so you see just the wireframe. If I change it to shaded, you'll see the shaded view. So now I'm going to select the face of the object. I can of course do multiple faces by just clicking on them. You do not have to hold shift when you're inside a command to select multiple. You can just click on them. If I change the output layer to instead of current but input, it will generate those faces, or those curves will be generated on the layer of the object you're working with. So in this case, those curves now exist on the walls layer because it was created from an object in the walls layer. Which is very handy. So I've extracted those curves from the object because they've already always existed. Cool. Okay, so that's general geometry and interface stuff. Any questions about that before we move to create some objects? Yes.
Sorry, at one point you selected just a few curves.
Mm-hmm.
You usually select things that are like part of an object already.
Well, if they're already embedded in the object, you have to use a command to extract them. So right now, those curves do not already exist. They do, but you have to tell Rhino to give them to you. So that's why I initiated a command to get them. So curve from objects, and you can see a bunch of different, commands. You can get the curve that's in the intersection of two different curves. So that's really cool. I'll show you that real quick. So if I move these two and they intersect, I want the curve that exists at their intersection. So I'm going to select both of these objects by holding shift and clicking on both. I'm going to go to curve from objects, and then I'm going to go to intersection, and that will then generate the curve that exists between both of them, which is awesome. Also, let's do another set of commands here. When you're going to modify an object, I always, this is like rule of thumb, always create copies, because if you make a mistake and you don't like the edit and you have to then Control Z, which is undo a bunch of times to get back to the original, that's a huge waste of time, especially if you've done a lot of edits and you've decided you don't like it. So always make copies. The fastest way to make copies is to do Control C and Control V. That'll paste it in the exact same place, and then you can just move them. Or you can type in the copy command, select the objects you want to copy, hit enter to get to the next step of the command. So that's another thing that happens. Some commands have multiple steps that you have to confirm. So if you type in copy, it'll say, what should I copy? You then select the objects and hit enter to get to the next part of the command, which in this case is point to move from. So I selected a corner of the object, but I can select anywhere within Rhino. And then point to move to. So I'm going to copy there. And right now it's set to multiple objects. I can set it to do one object and the command is done, but of course I wouldn't want to. You can also see a bunch of really cool commands here, like from last point, which is set to no. If I change this to yes, then the next object that I'm copying will be based on the original point of the first copy, and etc., which is cool. If that's set to no, then it'll be from the original place. So depending on the type of copying you're doing, that could be really important. Use last distance. So you can actually type in a distance. So if I want to copy it a specific distance, I can then type in 10 right in here, and it'll copy it by 10. And you can see it's locked it to 10. If I type in 20, oh, that's 1020. Let's undo that. 20, enter. It'll lock it to 20. If I want it to be orthogonal, I hold shift and it'll default to one of the cardinal orthogonal directions. So I'm holding shift right now. You can see the line turn white, which tells you that you are in fact in an orthogonal direction. Let's see. Okay, so if I let's type in 100. If I want to make copies every 100 feet, I can do that. So right now I've typed in 100. I'm gonna click, and then if I turn last distance on, and then turn from last point on, then it'll be 100, 100 automatically, 100 automatically, 100 automatically, etc. Which is cool. So I'm gonna get rid of all of these copies because I don't need them. So I'm gonna get rid of them real quick. I've created these copies just so I have the original object existing. So when I make edits here and I decide I don't like them, I just delete the edits and I still have the original object floating somewhere in space, which is cool. What I'm going to show you is a really cool command called Boolean. And Boolean has a bunch of different variations. If you want to merge two objects together, it'll delete any of the intersections that are inside the object. So if I wanted to create, so right now if I like zoom into this object here, and if your zoom is being weird, select the object you want to focus on and type in the command ZSA to then zoom to the object, and it'll start orbiting around the object. But if I go into the object, you'll see that their faces on the inside still exist. If I want those faces to go away and these to become one object, I'm going to type in Boolean, which is spelled B-O-O-L-E-A-N. And you'll see Boolean difference, which we're going to use, which will delete the difference of those two objects. You'll see, it'll delete the one object from the other object and create a whole. Boolean union combines them together. Boolean split deletes the intersection from the first object. Boolean intersection gives you only the intersection of those two. So we'll do an example of each one. And so let me actually make more copies so you can see them. So I'm going to initiate a copy command and select these, enter, and space and enter are interchangeable, by the way, which is cool. So I prefer using spacebar since it's closer to where my fingers are typically. So I'm going to type in Boolean difference. It's going to ask you select surfaces or polysurfaces to subtract from. So I'm going to select the main object and then hit space. And then I'm going to select the object to subtract with. I'll select the second object, hit enter, and now that modification has been done. So now this looks like a Morphosis building in LA. Let's say I wanted these to be combined. So I'll type in Boolean, and instead of difference, I'll use Boolean union. I'll select both of them at the same time and then hit enter. And now those objects are the same object, and you can see the space inside them has now been carved out. So if I turn on wireframe view, you can see inside that that space has been deleted. And if you look at the originals, you can still see their intersection still exists. Let's type in Boolean intersection. So I'm going to select both of these, hit enter, and enter. And now only the intersection itself has survived the culling or the deletion, which is cool. And I'm curious what Boolean split is because honestly I've never used it before. So let's see what it does. Select surfaces to split. So I'm going to select this one, for example, hit OK. And then select cutting surfaces. I'm going to select that one. Okay, so what it's done is it's left the original object on the inside and the outer object. So now I have two objects that have been cut and I can move around. So that's basically both of those existing. So those are, a bunch of really cool commands for manipulating geometry. If you're early in the design phase and you're massing, Rhino is king in massing. There are a bunch of different programs like SketchUp and FormZ, or not FormZ, sorry, that's an ancient program. FormIt, which is Autodesk's SketchUp. But I prefer Rhino. It's faster, it's more powerful, it's better in every way. Just take my word for it. Anyway, okay, so that's that. Any questions about Rhino geometry? Now, we're going to jump into Grasshopper now. And I'm going to show you why using Grasshopper brings me so much joy and flexibility. So let's say I've made these edits to these objects, and I want to do it a bunch more times. I have to redo all those commands again. So I have to type in Boolean. I have to type in the type of Boolean. I have to select the objects. I have to hit enter and space a bunch of times, and then the command is done. So every time you do that, it's one and done. With Grasshopper, you can create a workflow that automatically does all of those commands again. If you give it a different input, it'll run the commands and give you a separate output. And we're going to use Grasshopper to model a few things. And we're going to model a simple object and create a script for that. I think there are multiple types we can do. Like we could do an entire building, or we could do stairs. So if you have an idea of something you'd like to see modeled parametrically, just spit it out and we'll build it. But let's go ahead and launch Grasshopper. Yes. Keep it simple. I'll keep it simple so everyone can follow along.
Say spiral staircase.
Spiral staircase? Okay, that's one I've done already and is on the YouTube channel.
You did that one already? Okay.
I have. So another object?
Okay, so a skin, an undulating skin for a building that has
Louvers.
individual slices. So let's
Okay.
say that it's some type of a not really a mesh, but a
Sure.
segmented
Yeah, okay. We'll build that.
wave thing.
Okay. And as I'm building it, I'm going to be talking about different aspects along because there's a lot of things to consider when you're working within Grasshopper. Yes,
Try to follow along or just watch.
you should.
Okay.
I'll go slowly on this so everything I'm doing makes sense. But yeah, so let's go ahead and launch Grasshopper. So if you have Rhino 6 installed, Grasshopper should come preloaded. If you have Rhino 5, you need to go download the plugin for Grasshopper if you don't already have it installed. And so just type in Rhino 5 Grasshopper and you'll find it on Google very quickly. So let's go ahead and type in Grasshopper since I've already have it installed on my computer. And Grasshopper will open at the speed that you have, basically, like the more components and plugins you have installed, the longer it'll take to launch Grasshopper. So for most of you, it's already open. For me, it's going to take a little bit of time because I have like maybe 10 plus plugins installed. So I'm going to let that do its thing. And then we will talk about the Grasshopper interface. And then I'll walk through basically some simple commands. And then we'll build something really cool. And that will be the session. Let me think. Is there anything else I should show inside Rhino before we move on? Any other questions about Rhino before we get started? It's very simple, but it's powerful, and it's simple and complex at the same time. It's as simple as you want it to be, but it can be more. So I didn't even talk about a bunch of commands like move, split, divide, array, polar array, copy, paste. If you've used it before in another program, chances are it exists. So dive deep into those. Okay, so this is Grasshopper. Grasshopper is a separate window that opens, but again, it can only be open when Rhino is open because it's a plugin for Rhino. This is your canvas, which allows you to build your scripts. And anything that's built within Grasshopper does not yet exist in Rhino. You'll see a visual in Rhino, but you can't manipulate it in Rhino until you do what's called a bake, and we'll talk about that. But everything in Grasshopper, consider it a virtual object that does not yet exist, but you can see it. So this is a canvas space. I've snapped it to the side so I can see both Rhino and Grasshopper at the same time. But before we get into that, I want to keep it full screen so we can see all the things. Just like in Rhino, you've got a bunch of tabs that have a bunch of commands. You should have everything up to, I think, display, and then it's plugins that you have installed. Again, I have a ton of plugins installed on my Rhino, and this is why my Grasshopper. This is why my Grasshopper takes forever to open. But these allow you to do a lot of really cool augmentations. So get used to them, download them, explore them. If you're curious, how do I do a certain thing? Chances are you can either already do it within Grasshopper or there's a plugin that exists that does it as well. So you have your typical commands: geometry, points, vectors, circles, curves, planes, lines. You can build just about you can build literally anything you can build in Rhino, you can build in Grasshopper. Maths, which are just equations, so adding, subtracting, dividing, turning a number negative, larger than, smaller than. So if you're manipulating something based on, for example, its scale, and you're saying generate objects that are half the original object, you would use a math command to get the correct number for that. So again, you're basically telling a computer to do something, so you need to be very specific about each and every step so it does it correctly. Computers are dumb. They're really powerful and smart, but they're dumb, meaning they can't do something until they're told to yet. AI is getting super powerful, and that's a whole nother conversation. But right now, we control the computers and what they do, for the most part. So you basically need to tell the computer everything. Okay, now if you want to type in a command, you can either find something you want to drag, create it, drag it and drop it onto the canvas, and that will create its node. And the node is then existing in your Rhino canvas. Or you can double click within Grasshopper and type in point and hit enter. Now before you hit enter, there are a bunch of different types of point commands. So sometimes the command you want is like the second or third one, so don't hit enter automatically unless you know it's the one at the bottom. Or you can just click it yourself manually with your pointer and hit point. If you start typing, the typing will default to Rhino, which is kind of annoying, but kind of necessary, I guess. So if you want to select something inside Grasshopper, be sure to double click inside it before you start typing. Typing is always faster than hunting for a command at the top. But if you don't know what commands exist, hunt for them so you can know they exist, and then you can type them. If you're curious, like, hey, does this command exist? Just try typing it, and often than not, it exists. So, modeling and using CAD comes with a different language. As an architect or designer, You have to learn this language in school, so use this language that you already know in these new programs that you're learning, and oftentimes they already exist. So we're going to build that point move command. We're also going to change the way Grasshopper looks. Right now, the point here is simplified in terms of its size, and most commands are like that. By default, you can see G and T, but what the heck do those mean? If you are learning Grasshopper, I always recommend using the full display. So if you click on display at the top left-hand side, you'll see draw icons, which will turn the name into an icon, which is even harder to understand if you don't know Grasshopper yet. So I'm going to turn that off. And then I'm going to type in or click draw full names, which then turns the component into the full name, which I still use to this day, even after I've been using Grasshopper since 2015, so 4 years now, and I still use the full name. Because a lot of people, I send these scripts to a lot of people, or it's just easier for me to see. That does make the components larger considerably because it's spelling out the full name. So your scripts get bigger, but that's really not a problem because you have infinite space to draw. Okay, so I'm going to select one of these points here that I've created inside Rhino and reference it inside Grasshopper. So right now the components are, the point component is orange. Orange means I have no data, I am docile and don't know what to do. So orange is a warning color, and that just means, hey, and if you zoom in close enough, you'll see this bubble. It's telling you the warning that it has. In this case, floating point parameter failed to collect data, which means I have nothing. I have no data. So give me data. Gray means, hey, I'm happy. In this case, the move command doesn't have anything to do, so it's just happy. And then you can get a command, and red, the color red means error, which means something is fatally wrong. Fix it before I can be happy and do what you want me to do. So like I was saying before, inside Rhino or Grasshopper, the types of objects matter to the components you can to place them in. So I can't set a point inside a curve component or a surface inside a point component, etc. They have to be placed inside the correct name component. Now there are catch-all components like I mentioned before, like geometry is a catch-all. Brep is sort of a catch-all. It can take any polysurfaces or surfaces can work inside Brep.
And what is Brep?
Brep stands for boundary representation. But just think of it as polysurface, which is just multiple surfaces that have been joined together. So a rectangle or a cube is a brep and a polysurface. Those names are interchangeable. Rhino calls it one thing, Grasshopper calls it another, but they're the same thing. You can also have a data component. Data is also another catch-all like geometry. It can take any form of input that you can create, which is really handy if you're doing a cluster, but that's a whole nother thing. We'll get into that probably in an advanced session of Grasshopper. So anyway, to set a surface or an object or a curve or point that exists in Rhino, I'm going to select it in Rhino, and I'm going to go back to Grasshopper. I'm going to right-click on that component, and you'll see a bunch of options when you right-click. You'll see Preview, which turns the component's preview on and off, but it still runs. You'll see Enabled, which if you switch it to Disabled, the component is off and is no longer running. You'll see Bake, which churns Grasshopper's virtual geometry into real geometry that can be edited in Rhino, but it's then separated from Grasshopper and has now become a dumb object, so it's no longer part of it, but it's a copy basically. And that's one thing that's important with Grasshopper. Grasshopper makes copies. It never moves original geometry or edits original geometry. It always makes copies, and you'll see what that means in a second. Runtime warnings, which is just telling you what's wrong. In this case, I have no data. Wire display, reverse, flatten, graph, simplify. We'll get into what those mean down the road. And then set one point and set multiple points. In this case, we're setting 1 point, so I'm going to select 1 point. It's then going to ask me to select an object. I don't know why it's asking me when I already had one selected, but it did. Now that point has been referenced inside Grasshopper, and you can see that point component has turned gray, which means, hey, I'm happy. I have something referenced. If I zoom into this point, you'll see a little X around it. If I hide the original point in Rhino by typing in hide, you can then see the Grasshopper point is represented as an X. Now I cannot, again, select the object in Rhino because it does not exist. It's a virtual object. But when I select it, you'll see it turn green, which basically just tells you or gives you a visual of what you're selecting. Does that make sense? What it's doing? I'm referencing the Rhino geometry inside Grasshopper.
Yeah, I understand that.
Yeah.
I just that didn't happen on my screen, but that's okay.
What happened?
Well, like I don't see the point that I referenced in Grasshopper.
Is a command running, like select point inside? Look at Rhino. Is there a command that's running? Okay, let's try right-clicking on the point again, point component, and hitting set one point or set multiple points. Doesn't matter which you use. Yeah. So now go back to Rhino and select the point.
Yeah, I'm in Rhino.
Select. Do you have a point that exists?
Yes.
Okay, so select that point, and then hit enter, and now that point should be referenced.
No, that's okay.
Okay, I'm gonna come over.
Stop your flow here. Live miss. I'm so tired, so it's.
Oh, it's already referenced.
Oh, okay.
Because it's now turned gray.
Yeah. Also, when I click it here, it's.
Yeah, you can see it red.
Yeah.
So that's the point. So then you move this point. You see the reference
Yeah.
falls. It's already been referenced.
Okay.
Yeah. Also, yeah. So you can either select an object first, and then reference it, or you can do set one or multiple curves, and then select the objects after the fact. So you can do it either direction. Okay. So we've got our object reference, and real quick, I'm gonna show the point I've hidden. So when I select an object, I've got these move coordinate bar things that allow me to move the object in one of the cardinal directions. That's the gumball in Rhino. If you select an object and you go down to the very bottom right hand side, you'll see a bunch of tabs at the bottom. You'll see grid snap, ortho, object snap, and then you'll see gumball. Select gumball and it'll turn that on. You'll also see some rotation commands. In this case, it's a point, so it doesn't matter its orientation, but these bars right here allow you to edit its rotation. So if I go over to an object that actually matters that you rotate, let's say this one, and I want this to be rotated 180 degrees, I can type in 180 and hit enter, and now that object's been rotated, or I can just grab it and rotate it manually. So gumball is fun for, flexible modification. If you want to do something that's accurate or exact, I would type in the command, so rotate command or move command. That way you can have more control as to what you're editing, but if you're just moving things freely, the gumball is a great way to do that. When you have object snap turned on, you'll see all of the different options for object snap. You'll see end, near, point, mid, center. If you've used AutoCAD before, you know exactly what these mean. So I won't spend too much time on that. But anyway, that's just quick editing. Anyway, so let's go back to Grasshopper. So within Grasshopper, I'm going to move these guys out of the side. So now I have my command, and I have my what. So I have what and how. Now I need to tell Grasshopper by how much and in which direction. So in Grasshopper, to connect two nodes together, you click on the little circular, excuse me. In Grasshopper, to select two nodes together, you just you click and drag, and then you place and you let go. And that will connect two components together. And you can see that the point has already moved. So like I mentioned before, not all components need both inputs created to run. Some components have defaults. So for example, the default for move is to move it by 1 in the Z direction. But I want to be able to tell it in which direction I want it to move. So I have the how, I have the what, and I have the how. Now by how much? So in this case, I'm going to give it a direction component. There are three types of cardinal directions, right? There's the Y, there's X, and there's Z. In this case, I want to use unit Z. So type in unit, and then you'll see all of the other types there. So this will move the object in the Z direction. And now I'm going to create a number slider, and you can create a number slider by typing in a number straight up. So double click and type in a number. Or you can create a number slider by typing in number slider. This is the slowest way to do it. And when you type in number slider from the start, you'll see that it defaults between 0 and 1, and it has a bunch of decimal places in between. If you wanted to say 0, 1, 2, 3, 4, 5, 6, etc., you can change the scale of a number slider. So if you double click on the word number slider, you'll then see number slider options. You'll see R, which stands for floating point. So if you want more decimal places, use R. So if I want 2 decimal places or 5 or 6 decimal places, you can use that. If you have N selected, that stands for integer. It'll just read 1, 2, 3, 4, 5, 6, 7. E is even numbers, and O is odd numbers. So in this case, we're going to leave it at N. And then you can change the minimums, and your minimums can be negative. So if you want this to be, negative 10 to positive 10, I can do that. And then you can see the range is 20, so there are 20 numbers, negative 10 to positive 10. And then you can also change the numeric value before you hit OK. This matters if you've got a command that takes a few seconds to run, and you want to go ahead and set the number before you hit OK, so you're not waiting twice, and you'll see that later. But anyway, that's if you've got a really complex script. Our scripts are really simple today, so it won't take very long. But anyway, you can set the numeric value before you hit OK. And now your number slider goes from negative to positive 10, which is cool. So those are just one of the ways to input commands within Grasshopper. Is everyone caught up? Okay. Did you create the number slider? Okay. So you can either double click and type in a number. So if I wanted 20, or you can type in number slider, which is the slower way to do it. And the default number slider is always 0 to 1. Does that make sense? But we don't, that might be good in some cases. We don't need it in this case. So you have ultimate control as to what your number slider is. So I'm going to plug 10 into Z, and then plug the unit vector into motion. So now I have a moved point that is 10 units. In this case, if I double click, if I go to Rhino and type in units, I'll see the units that my Rhino is in. It's always important to know the units your Rhino is in, because Grasshopper runs on those same units. In this case, I'm in feet, and my absolute tolerance is set to 0.001. That's just how accurate the geometry is being drawn. The more zeros, the more accurate behind the decimal place. You can have it set to decimal, fractional, feet and inches, etc. I always keep it on decimal. But there are all the units that you can imagine are in here. You can use them. In this case, it's set to feet. So 10 here means 10 feet because Rhino is set to 10 feet. And now if I change the number slider, you'll see that that point is now moving. And so this is basically what parametric means. It's taking an original input, it's running it through a command, and it's giving me a new output. Now, you still see the original point, right? So like I said again, Grasshopper makes copies. It never moves original objects because it needs to read from left to right like a book. So it's starting at the original point, it's doing a command, and it's giving you an output. If I delete the original point, it doesn't know what to do and the command stops. So you're actually creating a copy. So the moved point lives here and the original point still lives here. So I can actually use both of these points to do a new command. So I'm going to house that new point in another point component. So now I have point 2 and point 1, and I'm going to create a line between them. So I'm going to double click, I'm going to type in line to create a line command. Before you hit enter, you'll see the first line is like point. It's a reference command or component, which means set one line or set multiple lines. That's not what we want. If I double click and type in line again, you'll see the second line is the one we want. It's a component that requires 2 inputs to generate an output. Those 2 inputs are a start point and an end point. We have those points. That'll generate a line between them. But I do want to show you the third line component. That is line SDL. And what that means is start, direction, and length, which is a vector. So if you remember from the original or earlier in the lesson, vectors can either be generated from 2 points or a magnitude and a direction. That's what line SDL is a magnitude, which is length, and a direction. So this is cool if you have only 1 point, but you still want to generate a line. If you have 2 points, then you use the other type of line component. Does that make sense? How that works? Okay. So I have the 2 original points. So I'm going to plug the first point into start and the second point into end. That component turns gray. And now if I zoom in, I have a line between those 2 points. And that line is based on those 2 points. So if I change either point, it's going to change the line as well. And that's what parametric means, right? So geometry that's related to each other that allows for parametric edits and a flexible workflow. So if I were to do this in Rhino, I would create a point. I would type in the move command or copy command, copy that point up, and then I would select those 2 points and use the line command to generate a line between them. If I want that line to change, I would have to move those points again, type in the line again, connect them again. So this is just, I want you to see the contrast between using these 2 things. With Grasshopper, the workflow has already been created. All I have to do is change the input. So let's say I wanted to set multiple points and have this done on multiple points at the same time. I'll just select all those points. I'll right click on point, set multiple points, and now the exact same thing has been done on all of those different points. And they'll all change at the exact same time, which is super handy if you're doing something cool like a truss or a structural system or a column, etc. Okay, so that's basics of Grasshopper. Does that make sense? Questions?
How did you get the green line that you're looking at now? What was that command that you typed in?
This one?
Yeah.
Line.
Okay. So
But there are multiple types of line commands. So if you type it in, you can see the icons are different. So when I type in line, the first line is this guy right here, which is just like the point command. It's saying set one line. If you go to the second one, which looks like that, you'll see the start point and end point.
Gotcha.
So select that one. And that's that. And then line SDL, which is start, direction, length. Okay.
Oh, sorry, one question. What's the difference, I guess, between those 2 again? Like, is it just you're giving it more inputs?
You're giving it different inputs. Yeah, so in this case, the start is a point, so we can use the original point there. It's going to ask for a direction. So in this case, let's say I want it to be unit Y, which is a direction. And then the length, which is how long I want it to be. So I can set that to be 100 or whatever. And it'll generate a line that starts at that point, that goes up by 100. Or in the Y direction by 100. And if I change the value, it changes the length of that line.
And before you were only using, so that's why I used it.
Exactly. Make sense? Okay. Now, this is something that's really cool. Let's say we wanted a direction that wasn't a cardinal direction. Well, vectors can also be considered as directions. So I drew a diagonal line here. I'm going to create a vector component, which is just like all of the other ones. And vectors are lines. Curves, though, cannot be vectors. Vectors are only straight lines because you need a direction. A curved line does not have a direction. So I'm going to select this curved line, and I'm going to set it to set one vector. Oh, I guess it's asking me to do a start point and end point. Okay, let's try that again. Vector, select one vector. Oh, I guess if I'm doing it inside Rhino, I have to then, let's edit the start point from here to here. Okay, or if I were to do line, select that line, set one line. Is it really having me draw the line again? Lame. Okay, so anyway, I have a line. Vector. I can plug that line into a vector component, and now that line has been changed into a direction. And I can plug that into here, into direction. And now all of those lines face the exact same direction, which is really cool. So if I change the original line, it should... Oh, I guess that vector is fixed. I wonder how... Let's see... Supposed to be able to set a line as a component. That's weird. Anyway, I'll figure that out. But anyway, that vector is now determining the direction of those lines because I've plugged it into direction instead of the Y. All right. So there's that. So let's go ahead and build an object. And as we're building the object, we're going to run into more things that I want to talk about. So I'm going to move these over here, and I'm going to disable them, which turns them off. So components that look like this, a dark gray, are off and are no longer running. And actually, I'm going to turn them on real quick to show you something else. Since this is the input, this is the start of the entire script. If I disable this guy, all the other components turn orange because their initial input is off. So this could be a way to pause a certain part of your script if you don't want that to be running as you're making edits. And then you can turn on an early component, and everything after it will then turn back on. So again, it's reading from left to right, start to finish. If you disable the start, you'll disable the finish. Okay, so let's say we wanted to make this curved line that I drew originally a wall. And then we're going to modify said wall in Grasshopper. So I've got this line drawn. Let's say that's a sight line that is based on topography in Rhino. So I've imported my CAD topography from AutoCAD, and I've created a surface from it using the patch command or a bunch of other types of commands. And this is the path that it's being drawn through, and this path is going to have a retaining wall, for example, just to set the stage. So I'm going to use the curve component to reference it. So in your case, just draw a curvy line, and then right-click on curve, and then set one curve. So you can see that line has turned red, and if I click on it, it'll turn green, which means that's the object I've selected. So if you're going to create a wall based off a curve, and you're thinking about in your AutoCAD mind, what command would you use to create a thickness for that wall? Offset. Offset is the best. So does Grasshopper have offset? Yes. Yes, Grasshopper has offset. So you'll see a bunch of different types of offset because you can offset surfaces, you can offset on a surface, you can offset lines and curves, which in this case is what we want. So offset curve. Yes. Maybe 15 minutes, 20 minutes. So offset curve. Offset curve has a bunch of different inputs in order to satisfy and give you the output offset curve. In this case, we're going to go ahead and satisfy all of those, so we've got something that works for us. In this case, we're going to set the curve here. So if I zoom in, you'll see that it's offset it by default. In this case, we want it to be offset by our default. So to create a number slider from the start that is already the number, like the min and max that you want to set it versus having to go in and edit the settings, what you type in is the lower number. So let's say I want it to go from 1, and then you use less than, and then type in the higher number. So let's say 20. And that'll create and then hit enter. And that'll create a number slider that goes from 1 to 20. So first number, less than symbol, last number, and that'll create the range you want, which is handy. So I'm going to plug that into distance. And now I've got my curve that's being offset by, however much I want it to be offset by. Let's say 2 feet. Actually, we'll just make it big so it's visible. So we'll say offset by 10 feet. This is like a wall that can withstand a nuclear explosion. Okay, so 10 feet offset wall. It could also be a path or whatever you want it to represent. It's dumb geometry that can represent anything. So now I want to create a surface between those two lines. And the way you do that in both Rhino and Grasshopper is a command called loft. And what loft does is it creates a surface between two or more lines. So in this case, I'm going to create a loft command. Loft requires curves, and it'll give you an output. Options just allow you to modify the type of loft that occurs. So if I do a loft command in Rhino, I'm going to copy this guy twice. Oh, actually, I'll copy and offset, a distance of 10, and I can pick the direction. So if I want it to go inside or outside, I can do that. If you want your offset in Grasshopper to go in a different direction, just give it a negative number, and it'll go in the opposite direction. Anyway, back to Rhino. If I select both of these curves in a similar location, Rhino is super weird. If you select two curves that are, if you select them at different points, it'll give you a warped surface. So just always select, it's weird. So just select them on the same side and type in loft. The loft command will then give you loft options. And so these options are the same as the options inside Grasshopper. So normal, loose, tight, straighten sections, etc. So we're just going to go with normal. And you can also add in control points and stuff like that. We'll hit OK, and that'll create our loft. In this case, it is backwards. And the reason why the surface is backwards is because our curves are flipped. So curves have a start and an end direction. And this is also really important to note when working with geometry. So if one curve is in the opposite direction, you can flip it by typing in the flip command, and that'll flip it. So when I then loft it, it should be in the correct direction. And it's not. That's weird. Loose. It's probably because the curve that I've drawn is really weird. If I draw a normal curve and I offset this guy by 10 and I loft them together, should create, okay, so there's a more normal curve, and it's generated a normal surface in between them. If I change this back to shaded, you will then see, or rendered view, which makes it look really nice. You'll see the surface that's been created. So I'm going to actually use these lines because these set of lines is giving me problems. So let's use these. So I'll copy them again because I love copying. Anyway, I'm going to delete the first line because I don't need it and just have one line. I'm going to set this as my original curve instead, so I can work from here since I know this will work better. And then plug in. So loft is asking for curves. It needs at least two curves to work. So I'm going to plug in both this guy and this guy. Now, it's replaced the first curve, which is not good. So how do I input multiple inputs in the same component? You hold shift. So I'm going to hold shift, and that will then allow me to add a second input into the same place. So shift, place, shift, place. And now the surface should have been created between the two objects. Where's my surface? This component ran twice. Let me flatten. I shouldn't have to flatten. It should be grafted. Where's my surface? Okay, I shouldn't have to flatten them. There's only two of them there. Okay, so I didn't want to have to talk about this now. I was hoping to have to discuss it later, but so when you're working inside Grasshopper, what you're doing is you're manipulating data. And all data inside Grasshopper comes in lists. So when you have multiple items in the same component, they're listed. And all computers start counting at 0. So if I have 5 objects, it will be listed 0, 1, 2, 3, 4. That's 5 objects, which is really confusing, but just understand that all computers start counting at 0. So I've got 2 curves here in the, or I've got 1 curve here in this component, and it's being run through here. And those are both getting plugged into here. So I want you to see what that looks like. So I've created a panel, and panel is just a way for you to visualize what's inside a component. So if you want to know what's in there, use a panel component. Right now the default color is this hideous yellow. So I'm going to right click on it, and I'm going to change the color to white because I'm OCD. And then set white as my default color, which you can also see there under options. So now all my panels will be white when I make them, and we'll get rid of this awful yellow. So that's just me. You can make it whatever color you want. If you want to do coded panels that tell you different information, like a calendar or something, you can do that. In this case, I'm going to plug in curve into here, and you'll see that that this panel is showing 1 referenced planar curve. That's identification number is 0. And if let's say I housed both the original curve and the offset curve in the same component. So I plug that into here, I hold shift and plug it into here. Now there are 2 objects, 2 values inherent in this component. If I plug that into the panel, you'll then see both of those curves. So you'll see the first curve and the second curve. And right now they're in a grafted state. So all data trees can either be grafted, which means each object is being treated as a separate individual object, or they could be in a flattened state, which means both objects are being considered as part of one tree, and they will act together as one. So we'll probably run into a point where this matters in terms of editing, but in this case, actually, we've run into that point now. In order for the loft command to work, it needs to see all of the curves in one tree. It didn't work originally because they were in a grafted state, and it was seeing just 1 curve twice instead of 2 curves once. So that's why it wasn't working. And there are, if a command that logically makes sense isn't working, flatten it or graft it, and it might work. So we'll plug that into here. And so now our command is working. And you can flatten either the input side or the output side if that makes sense for components. Sometimes it matters which one you use. But in this case, before I flattened it here on the actual loft command. Anyway, so that's generated our surface. And then from here, if you were modeling this and you wanted to create a wall and you were doing this manually like normal, what command would you use? Any ideas? If you wanted to create a wall from this surface?
Extrude.
Push, pull, and SketchUp, which is one of my favorite commands of all time. What would you use?
Extrude.
Extrude. And that's what we're going to use here. That's what Rhino calls push, pull. So there are multiple types of extrude commands that are all really cool, so get to know them. But we're just going to use the normal extrude, which will ask for a base and a direction. So in this case, this command absolutely needs both inputs put in for it to work. There is no default. So in this case, we want it to be extruded in the unit Z, which is up or down. But in this case, we're going to go up. And then I want it to be extruded by, let's give it a number slider that goes, that's pretty flexible. So I typed in 20. And whenever you plug in a number slider that's bigger than 10, it will default from 0 to 100. That's just the way it works. Or if you plug in one that's smaller than 1, it'll go from 0 to 1. Or 0 to 10 if you plug in one that's smaller than 10. But you can always change the scale manually. But now we have a wall that's being created at any height that we want it to be. Is everyone caught up here? Okay. Do you guys have a mouse?
No.
So it's touch screen.
Okay, we're pausing for an emergency. We're going to fix this real quick. Oh my gosh.
We're like touch screen and finger pad.
This is unacceptable.
You guys are doing better than me. I lost
Do what?
Okay, so
Why didn't you stop me?
because you're recording, so we don't want to stop you while you're recording. All right, so this
Here's
is,
your mouse.
Thank you so
You're
much.
welcome.
This second curve, where's the data coming from for that second curve that you created? Oh, sorry, I guess I should.
Oh, yeah. So hold shift. And now two curves. Oh, you can let go now. Oh, hold. That's right. Yeah. That's
And
right.
it keeps doing that. I don't know if. Oh, I see. It's just you.
So now both curves are referenced in the same component.
I understood. Okay,
Yeah.
and then we put that in loft. Okay,
Yes.
I'm with you.
Okay. You can watch this video later.
Yeah. Indeed.
All right. Okay, so we've got our extrusion here. So let me just zoom out so you can see the whole thing. Okay. You good?
Yeah.
Okay. All right.
The red. Well, we've got a red. Not that red. We got a. The
Got it.
loft. Our loft is red.
What'd you plug into it?
That second curve and then the unit Z.
You don't plug in a
Oh,
unit
no.
Z into a loft.
Until. Well. Oh. On the other side?
Yeah. No. That's an extrude component.
Oh.
You don't plug in a unit Z. Like hold Control to cancel, and I'll show this on the screen. This will where's this?
Oh, sorry.
Hold Control again.
Control?
That will disconnect. You want to plug that into an extrude component.
Okay, and then this one is it's dashed. Does that?
Dashed means it's grafted, so you want to flatten the list, and that's another thing I want to mention up here too.
Okay, we talked about that.
Okay, let me actually move this down. Okay, so two questions that I think everyone should know, obviously. So they got an error when they plugged in the unit Z in the options. It's not something that the loft command is looking for or can process. So the component turned red, which is bad. So there are two ways to disconnect something that you've accidentally connected. You can either right-click on it, go over to disconnect, and select it there. Or if it's already connected, you can use Control, and so you'll see the minus guy, and you just reconnect it like that, and it'll disconnect. So those are the two ways to disconnect. Also, in their unflattened list, they had a different line type, and the line type just tells you whether or not you have a flattened tree list or a grafted tree list. So if it's dashed like you see here, it's grafted, which means there are multiple trees inside it. If it's flattened, it turns back to a solid line, which means it's one tree with multiple items in it. And so loft command needs a flattened list in order to work properly. And then what we're doing, since it's created our surface, which you can see down here, then we're plugging that lofted surface into the base of an extrude component. So this is the new output that's becoming the input of another command. And then that command is being extruded in the Z direction to create our wall. And so now that we're here, we can move forward. So this wall is being created by 6 different surfaces. Now, like I said, in Rhino and Grasshopper, you can extract information from any part of an object. So I can get a specific surface from this wall. I can get a specific curve from this wall. I can get a specific point from this wall to then do multiple or different types of edits later on. So let's say I wanted to create a pattern on this wall. Well, I could do that pattern on all the walls, but I only want to do it on one face, let's say. How do I get this face of the object? This extrude command holds the entire B-rep or poly surface together in one. It's being treated as one object. But if you want a specific surface or a specific point or a specific curve, use the command called deconstruct. And deconstruct is very powerful, and there are a ton of different types of deconstructions. Deconstructions are used to extract specific data types from an input. There are also constructions, which take multiple data types and creates something from those data types. So you can go in either direction. In this case, we're going to deconstruct the B-rep. And you'll see that you give it an input B-rep or B-reps. It will then give you its resultant faces, edges, which are curves, and vertices, which are points. So faces are surfaces, edges are curves, and vertices are points. So when I plug this extrusion into B-rep, you'll then see that the object has been exploded. So this is basically exploding, like you would do in AutoCAD or Revit. Actually, not in Revit. You don't explode objects in Revit. Yeah, sort of, but not the same way. So anyway, so I've exploded this object. I now have the faces, the edges, and the vertices. If I plug a panel into faces, just so you can see here, it's got 6 faces, counting from 0 again. So 0, 1, 2, 3, 4, 5. That's 6 faces. And each face has a number and identifier in the list. So, you know, this top surface has a number. I'm not sure which number it is yet, but it has one. So there are ways to identify which one it is in this list. It's not always the same. Sometimes it's different every time, which tends to cause some issues in Grasshopper that you can fix. But anyway, now let's say I wanted this face here. I wanted one face, one surface out of the B-rep. How do I do that? How do I grab one thing from a list? You use the command called list item. So each one of these numbers is an item. So this is the 0 item. This is the 1 item. This is the 2 item, etc. And these are indexes. So the identifier that it has is called an index. And the object itself is the item. So index, item. Index, item. So, and it's asking for a list. List is another catch-all. In this case, right, this data is a list. Even though it says faces, it's a list of faces. So I'm going to plug that in the list. And then I'm going to create a number slider that goes from 0 to 5. I don't need any other numbers. If I plug in a 6 into a component that goes 0 to 5, it'll just restart, and the 6 will be the 0 item. So that could also cause problems if you're working with a lot of things. So just give it a number slider that is as big as the list is. So
0 to 4 if we go to 5.
We can go to 5 because there's an item number called 5. If we plug in a 6 into index, it will go back to 0 and start over. So 0 less than 5 will give me a number slider that goes from 0 to 5, which is as many numbers as I need. So when I plug that in the index, you'll now see that one surface from the object has now been selected. That is the 5th surface. If I change the number slider, it will then change which surface is active. Now you can see a bunch of different surfaces are overlapping, which is creating some visual issues here. That's because all of these objects here are being previewed, so I can see them. So I don't want to see them. So I'm going to select them all. I'm going to right click and I'm going to hit preview off. So now all I see is the component that's still being previewed. So that surface is the one being previewed. I can change which one it is. So if I go through the number slider, it's selecting a different surface from that B-rep. I'm going to turn on the original object as well. So just so we can see it. So we can see where we've come from. We've come so far. But now we have that surface. And now I can do whatever I want to that surface. So if I wanted to extrude it, I can do that. If I wanted to move it, I can do that. If I wanted to divide it, I can do that. And the original objects are still the same. But this is how, for example, if you're doing a building facade and you wanted to create windows and panels, you want to grab a specific surface and manipulate that surface. And all of those edits will work their way through. So in this case, let's do that. We're going to divide it a bunch of times to create our panels. And then once we've done this, we're going to close the session. I'm probably going to do another Grasshopper session because there's so much more that I've yet to even show. But this was mainly meant to be a primer for those who are completely unfamiliar with Grasshopper and want to understand how to use it. So we're going to divide this surface a bunch of times to create our panels. Just to show you though that you've got that surface, you can do manipulations. So we could do something like a divide surface, which will divide an input surface by a U count and a V count. The U count is the X direction and the V count is the Y direction of a surface. So you can see it's straight up, but every object has a U and a V direction that's separate from the X and Y direction. So we're going to use, I can plug in a number slider that goes to 10, or actually I want it to go bigger than that. So I'm going to plug in a number slider that goes to 100. To quickly copy things, it's weird, it's backwards in every other program, but you have to move the object first and then hit Alt to create a copy. Super weird. Like in Adobe programs, you hold Alt and then move. In Grasshopper, you move and then hold Alt. It's very weird. So the U direction, as you can see, is up and down, and the V direction is going to be left to right. So that's dividing it into a series of points. The U count I don't want to be nearly as high because it's not as tall, so we can say 5 by 100 division. That looks pretty cool. But this is, just one of the ways you can do manipulations on specific objects from a B-rep. Now, just to show you how flexible this is, let's say I wanted to repeat this entire process on a brand new line. I can do that because Grasshopper has been set up. One of my favorite analogies from someone I was showing Grasshopper was that it's basically like showing your work in math class. So this is my entire workflow right here. I've basically built it out. It's like I've written a paper on how to build a wall right here in Grasshopper. So if I select this curve and I go way back to the beginning and make that my main curve, the entire process is going to be automatically done on that new curve. So let's say your design changes and you don't want to have to rebuild that wall, so offset, loft, extrude, explode, select the surface, run a divide surface command, etc. You can have that it's already been built out in your script. Make sense?
Yes.
Cool. Okay. We're going to go back to the original one. So I'm going to set that as my main curve, set one curve, and then go back to it. In this case, I just wanted to show you the divide points as like one option of a type of manipulation, but we're actually going to disable these. We're not going to use them. We're going to do another command that's going to divide it into panels. So we're going to use what's called an ISO trim, which is going to ask for a surface and a domain. And then we're also going to use a divide domain command. Domain squared. So divide domain squared. There's also divide domain single. You want to hit the one that has a little 2 on it, because that will allow us to divide it in both the U and V directions. Do you see it?
Yes.
Oops, that was divide domain 1. That's not what we want. Actually, well, it could be, but let's go with divide domain squared. Okay, so it's going to ask us for the U count and the V count. I'm going to use the same numbers that I used last time, so I'm just going to move them first, then hit Alt to copy, and then I'm going to enable them, and then plug those into U and V. Now you don't see anything happening yet. This command does not create a visual. It's more like a series of numbers or instructions. So if I plug the segments into here, right, this is just a series of instructions for another component to execute, and that component is the isotrim component that we created. So the isotrim is requiring 2 inputs. Are you guys caught up? Almost? Okay. Sorry, I tend to move really fast.
No, that's fine. I'm just getting to where we can plug in facts.
All right. So then I'm going to plug in the list item so that the surface lives here, right? In the list item command. We're going to plug that into surface.
We're messing up. What is it? Does it say pixel or camera? What is it one to the? What is that one to?
That's just a panel.
Oh, just okay, gotcha.
It's just a viewer.
Okay, we'll call it.
Okay. So we're going to plug in item into surface, because this item has a surface in it, and then our domain will plug into domain, and this will create a visual on the surface, and that visual is basically a panelized surface that we can then do further manipulations on. So let me know when you're here.
Oh shit.
So let's say this is a wall with a tiled pattern on it. Or this could be a curtain wall on a really long and short building. Or any other types of geometry that you can think of. So each one of these panels is an individual surface. So if I plugged in a list item in here, I can grab the 131st surface, if that matters. In this case, we're going to keep them as a group. But if I plug in a panel in here, I want you guys to see what's in here. You can see a bunch of untrimmed surfaces in here. So these are all of the surfaces that are inside this component right here. So panel is a great way to see what's inside a component. I highly recommend using them often and always. So there's 500 different surfaces in here because I plugged in 5 in the U and 100 in the V. 5 times 100 is 500. So I've got all of these surfaces in here. And what I could do then is extrude these surfaces. Now, here's something that's really cool. So again, you can extract any information from an object. So one cool thing about surfaces is that every surface has a direction as well. And that direction is called a normal. So, and that's perpendicular from the surface. So if I have a surface here, and I want to know the normal of that surface, the normal of that surface is this direction. And it will always follow the surface. And so I was doing for those on the live stream, I was doing a physical example with my phone. But I'll show you what I'm talking about there. So a surface will always be in the center of an object, and it will be perpendicular. So I'm going to switch to front view, and gosh, there's so much I want to show, but we have time constraints. Okay, so I switched to front view so I can draw it upwards, but that's the normal of the surface, and if I rotate that surface, the normal will follow it. So it's always coming out of that surface perpendicular to it. So you can see all of these surfaces here are curved and facing different directions. So I can extrude them in the X direction or the Y direction. But because it's a curved surface, those directions will not be correct for every single one of those objects. It's going to create slanted tiles, right? That's not what we want. We want them all to extrude in the direction that they're coming from. So if I want to give them a thickness, let's say it's a tile, then I want to extrude them by their normal. And to get a normal of a surface, you want to get its center point, which is the centroid. And centroids are tied to area components and volume components. Nope, that's not what we wanted. And I'm going to go a little bit faster here,
Sure.
just so we can see things. So area components give you the area of a surface and its center point. So the area can be plugged into a panel, so you can see how big each one of these are, which could then help with area calculations or cost calculations or stuff like that. I actually have a script right now that's giving me the area, the gross floor area of every building in our massing development, and I have it plugged into a cost estimator, so it's telling me how much each massing will cost based on how big it is, which is cool. And we also have the centroid point, which is a center point. Now what I want to do, and I'm going to go quickly here, is use the surface closest point to locate the surface on the point and give me the U and V point. So for those on the live stream, I am going to go a little bit faster, but feel free to rewind the video and go back to it, or pause or rewind, or etc. And then I'm going to use a command called evaluate surface. So all of these commands I know because I've run into situations when I've had to use them, and I did a Google search on how to use them. But I did the Google search and found the answer because I knew the terminology to ask for. So it's important to take a deep dive and learn what you can evaluate. I guess I spelled it wrong. Surface. Okay, there it is. To learn the typologies and to learn the types of commands you want to use to do what you need to do. So I didn't know all of this at the beginning. I just used Grasshopper every day for every project, and I learned as I went along. So now I've got the plane of each one of these objects here. I'm going to hide some stuff so it's easier to see. So hide that, and I'll hide the original geometry there. And so that plane is basically giving me a brand new world coordinate for each point, and which is the normal. And so you can see the normal is one of the outputs here. I can use any one of these outputs to do something else. I don't need to, but they're available for me to use later on. So I have that center point, I have the normal, so I'm going to grab an old friend that I told you about earlier, line SDL. So I'm going to copy that. Or actually, I'm just going to retype it because it's plugged into a bunch of stuff which I can just replace, but it'll just be faster if I retype it. Line SDL. The start point is the point, and the normal is the direction. The normal is a vector, a magnitude, and a direction. And it really doesn't matter what the length is. I just need, actually the length will be the extrusion that I'm going to use. So let's say it's 3 feet, which is pretty long, but we can make that smaller. So now that line has been extruded, let's get to a view where we can see it. So I'm going to hit CSA. Okay. So you can see that's now giving me a normal. Those are though facing the wrong direction, right? That's the inside of the wall. I want them to go the other direction. So I'm going to plug in a negative number. And if I don't want to then manipulate this number slider to go negative, I can just create a negative component and run the number through it. Now that number is negative, and I can then just plug that back in here, which is like the fast and easy, lazy way to do it. But it's really handy if you've got like a different, or if you've got a set of numbers that aren't being determined by a number slider, that you're getting from another thing. So negative component's great. So now they're going in the correct direction. And then I'm going to use a different type of extrude command. So earlier we used a extrude command that was basically base and a direction. In this case, we're going to use extrude along. And what extrude along does is it says, I'm going to extrude an object by a curve. And that curve is our normal that I just drew here. So I'm going to plug that into here. And the base are our surfaces, which are way back here. So I'm going to go all the way back here and plug these, skip all this guys, and go right to base. And now all of those have been extruded by their normal on the surface. And so now we've got all of our tiles. And again, this is parametric, so if I wanted to make these longer, I can make them longer. Or I can make them shorter. It just depends on what the eventual output needs to be. But this allows for maximum flexibility when you're working with them. Let's say you wanted to give in a little bit of space for a mortar. So one thing you can do is scale all of those objects down based on each one of their center points. And so this is one of the reasons why a grafted list or a flattened list is really important. So what I'm going to do is I'm going to graph these guys. So each one of them will be treated as their own individual object, operated on by their own parameters. I'm going to get I'm going to use the original point here from the normal, and I'm going to scale them down by 95%, so they'll be slightly smaller than it used to be. So so to do that, there are two types of scale commands. There's scale normal, which is just scaling by a certain factor, and it's a uniform scaling. And then there's scale non-uniform, which you can scale things specifically by in the X direction, Y direction, or Z direction separately. So you can actually input a different command for each one, which is handy. In this case, we're just going to use the uniform selector, a scale. It's going to ask for a center point, and right now it's running it on all of them, and there's a lot of them, so I might actually reduce the number of them so it processes faster. In this case, I'm gonna reduce this down to 20, so they're gonna get a lot larger. But I just want there to be less to compute, so it goes faster. Okay, so it doesn't look nearly as cool, but it'll be easier to manipulate this and build the script, and then I can just go back to 100 later. Okay, so now I've got them, and the center point is going to be the point I use to generate the normal. I could use an area component to generate a centroid, but that will be right in the center of each tile, and when I scale it, it's going to get smaller and come off the wall. That's not what I want. I want to scale it based on the point that was used as the original point to extrude them, so they always extrude in relation to that point. So I can use whatever point I want. I could place a point out in space, and they would all scale to that point out in space. But I want to use each one of their original center points to do so. Uh-oh. Have I frozen Grasshopper? Did I do something? Okay, so this is also really important. I know what's happening right now. It's scaling each one of them by all of the points. Okay, this is why list management is really important. So I'm going to make sure. Okay, so my computer's humming along, but I think I've frozen Rhino. Okay, one sec. I probably didn't even have to graph them, to be honest. Okay, let's let it do its thing and think. Okay, yeah, so what it's done is it's scaled all of them by all of the other points. That's not what we wanted. You want your lists to match, which is really important. So if I look at this point here and I plug it in, this list does not match this list. So if I want to create a manipulation on all of them and I want it to work correctly the first time, make the lists match. So this is a grafted list with each entry acting differently. This is a flattened list with all of the entries separate. So when I plugged this into the scale command, what it did was it applied 100 different points to each one of the B reps and gave me 100 times, however many of what I wanted. So, and you can see that it's because it's scaling some of them on some points that are far away, it's done a really weird scaling thing. So that's not what we wanted. We wanted all of them to be grafted. So now the lists match. So I can either graft it here or graft the original over here. But because there are other commands that required it to not be grafted earlier, I didn't graft it here because it will then graft everything else after it. So you can graft it. You can pretty much graft the list wherever you want. But now these match, right? And you can see that they all got smaller than the original. And I'm going to plug in a factor, and factors go between 1 and 0. So I'm going to type in 1.000. Actually, I'm sorry. It can go over. If you go less than 1, it'll get smaller. If you go more than 1, it'll get bigger. In this case, we want them to get smaller, so we just need a number slider from 0 to 1. And I'm plugging in 1 right now, so they'll be the size they were originally. But if I can do like 0.995, that'll make them slightly smaller and create a space. So let me hide all of this stuff so the visual is gone. So I'm only seeing the edits. And we'll do a ZSA so we can quickly and easily flow here. But You can see that the margin, let's keep going. Let's make it 0.9. Here we go. Because they're not square, it's it's bigger on this side than this side. There are ways to get them even, but you have to plug in the right number. And there are ways to say I want that scale factor to be a specific inch. So to do that, you would divide 3. So like because Grasshopper is in, or Rhino is in feet, that's 3 feet. If I wanted that to be 3 feet in inches, you would just do simple math. So you would divide 3 by 12. So division, plug that into here. And the result is then, or is it multiply? It's multiply, sorry. Multiplication, so I'll plug this times that. And that's 36 inches. Now basically, or that's 36 feet. So I was right, that is 3 inches. Sorry. That's 3 inches, 0.25 a foot feet is 3 inches. And let's say but I need a scale factor. So what I need to do is then divide this by if I want the length to be 3, create a scale factor. So what I'm going to do, okay, actually that might just be more. I don't want us to be here forever. It is possible to then, basically what you have to do is take a length that already exists and subtract it for the length that you want it to be, and then turn that into a scale factor. So it's just a lot of math and component plugins, so we'll skip that. But anyway, for now. So I'm going to unhide the original object, which is over here. So now we've got our panels on it, and I'm going to go back to 100 so it looks cool, and then wait for it to process. To give us all of our shapes here. Let's let it do its thing. I heard the beep, so that means it's done thinking, right? Okay. So there we go. We've got a panelized wall that looks pretty cool, and now we can bake it. Now we can, if we wanted it to be done on both sides, we don't have to build all of this again. All we need to do is give it multiple inputs, right? So this guy, if you remember, so there are different ways to view data. So the green guy up here, if it's turned on, it shows you everything that is being previewed within your script. If you turn it off, only what you select will show. So this is a great way to like troubleshoot scripts if something is weird or you want to find something and you don't remember where it lives. Turn that on or off, or on, or whichever way it is, and you can select the component and find it. But in this case, I plugged in one number slider here to grab one surface. If I plug in another slider, so I can just copy this guy since it was formatted already, and make this, let's make it 4. I don't know what the other surface is, so I'll just kind of, I'm going to disable this so it doesn't think. And then plug this in so I can identify if I have the right surface before I then let it think. If I didn't do that, it would process. Every time I change this number, it would process again and take forever. So in this case, I'm going to wait for it to, there it is, so I know it's 4. Now I'm giving it 2 surfaces, and I'm going to turn this guy back on and wait for a second so it can think and rerun everything else. And now it's on both sides of the wall. So it's all about thinking about inputs and outputs, thinking about where commands are running, which commands are heavy to get your geometry, which commands are light. Grasshopper actually tells you how long it takes for certain components to run down here. So that took 7 seconds to do both. What I need to do from here, and this is another reason why flattened lists are so important, or flattened or grafted and being correct there. I'm giving it 2 flattened surfaces, and it's not running correctly. It's treating both of them as one, And so you can see it worked properly on one side and didn't on the other side. So I need to graft this list. So both of those surfaces are being treated individually, and it's running the command on both of them as if they were both a single surface that I plugged in. So now it's on both sides, and so I can then do something different with the top if I wanted to give it a cap, and then extrude that cap so it's now like the cap of the wall. If you're doing like a parapet or something, you can manipulate any portion of that surface and do something different. Now, like I said again, all of this is virtual geometry. I cannot edit it within Rhino. Let's say I wanted to get to a stopping point and I wanted to see what these looked like in Rhino. I'll then do what's called a bake. So I'm going to grab this guy houses my tiles. So I'm going to go create some layers here because I'm going to bake them to a specific layer. So I'm going to create a master layer called wall. And I'm going to create some sub layers. So I'm going to create tiles and grab that into there. And I'm going to create another one called base. Okay, so I'm going to grab my scale guys. I'm going to right click on scale since it houses my tiles. Bake. I'll then see all the layers that I've created. Click on tiles, click OK. And then Grasshopper is going to turn those into real Grasshopper geometry or Rhino geometry that I can then select, which is super cool. So there they are. And then I'm going to go back to the original extrusion way back over here and bake that into the layer called base. And then I'm going to turn off the Grasshopper preview and make Rhino full screen. Grasshopper will always show above, so I can minimize Rhino or Grasshopper, and Grasshopper is now down here, so don't forget about it. And then I'm going to turn on shaded view, and then we'll turn on rendered view and see what that looks like. But all of that work to do manually would have taken a very long time. But with Grasshopper, with Rhino, all of the work is distributed throughout, but you have to repeat it multiple times if you want a different result. With Grasshopper, all of the work is front-ended, but once you have the script done, the rest of the work is super fast and easy. So it just depends on where you want to spend your time. Do you want to spend your time creating a framework that's easily manipulable and easy to create, or do you want to spend it on the back end making edits later on? But now we've got the super awesome wall that is sitting on our site. It's looking really nice. We can then render it and be done. Now, again, this is separated from Grasshopper. So this is a dumb object now. So if I select it, and I don't want to move the original curve because the original curve is in there. So one cool command about Rhino is called the selection filter, and this is one of the last things I'll show, I promise. If you type in selection filter, oh, I just turned it off, but I'm going to turn it back on. You'll see points, curves, surfaces, polysurfaces, meshes. These commands allow you to turn on and off selectable assets. So if I unselect surfaces and polysurfaces and I select over this, all that's going to be selected is the curve because it's the only one in this area that's still active. So if I want to do the opposite and select the surfaces and polysurfaces and turn off the curve, because that original curve is still being referenced in Grasshopper, if I move it, it will move everything and it'll have to compute everything again. I don't want that. I just want to move this iteration that I've now baked out to the side and then go back to Grasshopper, turn on my visual, and you can see the original is still there. I can make edits, bake again, move it over, and compare the two. So this is what I used to do in school when your professor was like, give me 50 iterations. I would just write a script and generate 50 iterations really quickly and be done in 2 hours versus everyone else who took all night. So Grasshopper was a super powerful tool in school. If you're still in school, and a lot of you are, awesome. This is a great time to learn Grasshopper so you can get through your studio assignments later. If you're a professional, this is great if your client's like, I want to see 5 options, and now you can model your 5 options in 5 minutes versus 5 hours. So that's the power of Grasshopper. There's so much more you can do with it. I've built entire cities within Grasshopper alone. I've been using it for every single project, and this is the best way to learn it, is to apply it to every project. That way you're learning about all of the different things you have to learn about, because Grasshopper, it's simple to use, but it has a lot of rules, kind of like Revit, but more flexible. And Revit actually has a Grasshopper-like plugin called Dynamo, and Dynamo is actually on the roadmap for a later session, and I'm really excited about the Dynamo session, so stay tuned for that. That's going to be in August. So if you don't want to wait till August, jump into Dynamo now on the internet. There's plenty of tutorials and videos there. But thank you guys for coming to the second session of You're Doing It Wrong. The next session will be next month on InDesign. So if this is, a lot of students have been going through their portfolios, and a lot of professionals don't know how to use InDesign, which blows my mind. But if you don't, come to the session in May. I'm going to be talking about how to use and optimize your workflow and use it better. So thanks for coming. I'll see you at the next session next month. Have a great day. See you later. Bye. Okay, so I'm going to end the stream now. Oh, that's the point that they're at right now, which is funny. Okay, so I'm going to end the stream. So, end stream.